Okay, everyone, what we're going to do is we are going to start section 2-3. And so, section 2-3 is going to start out, now we'll get into some other things, but it's going to start out with the unit circle. Okay, the unit circle. Now, what is the unit circle? Well, if we have a coordinate plane, then we say that the unit circle is the circle that goes around that coordinate plane and has a radius of 1. So that point right here would be the point 1, 0. Now, what's great about this unit circle? Well, first of all, if it's a circle with radius 1, it's going to have an equation like this. So we know that the point AB is on that circle. Anywhere in red there, anywhere on that circle exists the point AB. Now what we're going to actually do is we're going to use this unit circle to help determine our trigonometric functions. So let's say this. Let's suppose that we have an equation an angle in standard position. So the initial side is coming right through here, okay? And let's suppose the terminal side of our angle goes right there. Initial side, terminal side. This point right here, this would be the point AB. Wherever that terminal side crosses wherever it crosses our unit circle is the point AB. And so we say that this particular circle gives us the radian measure. So what's that mean? Well, that means this angle here, this angle right here, is x radians. X radians. So it could be, pi over 2, 2 pi over 3, 6 pi over 7, whatever the radian measure for the angle is. But notice, not in degree measure here, okay? Now, we can think of radians in terms of degrees. If it's going to help you think about it a little better, that's fine. But a lot of times we're going to discuss angles in terms of their radian measure. We'll talk about that a little more in just a minute. So what can we get off of this? Well, we can determine our trig functions. Sine x, cosine x, tangent x, cosecant x, secant x, and cotangent x. So, what is sine x here? Well, sine x is always going to be b. It's always going to be the b of our point right here. Now, remember, our point is A, B. And so, sine x will always be b. So notice, sine x is the y-coordinate of that point, essentially. Sine x is the y-coordinate of the point. Cosine x is going to be a, so cosine x will be the x-coordinate. Now, if you remember back to chapter 1, tangent was y over x. So this is going to be the same thing here, b over a, the y-coordinate over the x-coordinate. Now this is as long as a does not equal 0. Because if a equals 0, obviously the fraction would be undefined. Now, essentially, cosecant, secant, and cotangent are inverses. Okay, so to find cosecant, it's the inverse of sine. So its answer would be 1 over b, as long as b does not equal 0. This would be 1 over a, as long as a does not equal 0. And cotangent, instead of b over a, it's the reciprocal of that fraction, which would be a over b, as long as b does not equal 0. Okay? And so this is our unit circle that we're going to use to try to define some of these functions, okay? Now, it's very important for you to note that sine is always the y-coordinate, cosine is always the x-coordinate, and that tangent is always the y over the x, okay? Always the y over the x. Now, the answer to this would be in radians. So b, whatever b is, would be a radian measure. But a lot of times we identify angles by the radian measure. So instead of saying the angle with radian measure, let me go to the next page, it'll be a little easier. The angle with radian measure, instead of saying the angle with radian measure pi over 2, a lot of times we'll identify it by its radian measure. We'll say the angle pi over 2 instead of the angle with radian measure pi over 2. Okay, so we identify the angle a lot of times instead by the radian measure instead of finding the angle with that radian measure. So for instance, if I asked you what the sine of 270 degrees is, well, that's fine. That's in degrees. You can understand that very easily. But we might also identify it with its radian measure, the sine of 3 pi over 2. These are 270 and 3 pi over 2 are one and the same. One of them is just the radian measure, one of it's the degree measure. So we identify it with that. And this would be, this would actually be -1 for that answer, because the p-value is 0, -1. And so since sine is the y-coordinate, remember, this would be our answer. This would be our answer. Now, the world is fine and the world is great as long as the world is fine, the world is great as long as we keep everything on the unit circle. But as you know, in real life, we don't live in a perfect world, okay? So every little problem we have is not going to fall on this unit circle, okay? We might have some arbitrary AB, okay? It might be some arbitrary number, meaning it can be any value. And so how do we relate that to the unit circle? If this P is not on the unit circle, how do we relate it? Well, the P may not be on the unit circle, but where it lies on a terminal angle that is on the unit circle. So for instance, if we had a nice big unit circle drawn here, okay, nice big unit circle, and this was our angle, but they gave us this point way up here. Let's say this was the point -3, 5 or something like that, some random point I just picked. Notice that's not on the unit circle, but this point is. Okay, this point is on the unit circle. So these 2 points are on the same terminal line, if you notice. So because of that, we can relate it to the unit circle. We just say it has instead of having a radius of 1, everything's nice and neat here. Because if you notice, if you remember, our sine x equals b, cosine x equals a, and tangent equals b over a. Now, these are understood to be over 1. Now, what does that 1 represent? That 1 represents our radius of this unit circle. The radius of a unit circle is always 1. So that's why those are understood to be over 1 here. Well, what happens if we have a point like -3, 5? Well, then our radius is no longer 1. So we have to adjust this value. We have to adjust this value on our problems. So really, it's going to only affect your sine, cosine, cosecant, and secant. And so here's how it will affect that. Here's how it will affect that. And I'm sorry for having to do this. It's the way this PowerPoint works. What we have to do is this. With the unit circle, we know that a squared plus b squared equals 1. Well, if b is not, if 1 is not the radius, then we have a squared plus b squared equals some r squared. That's the equation of a circle that you learned in college algebra. It also looks like the Pythagorean theorem, I know, but that's an equation of a circle, okay? So, don't get it confused with the Pythagorean theorem. But if we solve this for r, we get the square root of a squared plus b squared equals r. Okay, the square root of a squared plus b squared equals r. So this allows us to find that missing radius. You know, remember I told you the 1 on the bottom would change. So what's this mean for our point here? Well, instead, with the unit circle, we have the point AB. With a circle that has a radius that is not 1, we have the point A over R, B over R. So here is where notice our radius has changed. It's not the understood 1 that it was with the unit circle. It's just some random radius. That's what I'm trying to get the point across. That's why the other one, that's why it had the understood 1 underneath the A and the B, is because the radius was 1. Okay, hopefully that's gotten across. I keep repeating that, so obviously you know that that's very important. Understood. If we have this is our unit circle here. If we have a radius of 1, then these are our answers, right? Because they're understood to be over 1, which is our radius. But here, we don't have a radius of 1. We have some arbitrary radius, so we have to make an adjustment. Okay, and so these would be our points for P. So these points also lie on the terminal side where P is. So we would say that sine of x now is b over r instead of just b. Cosine of x is going to be A over R instead of just A. Now tangent, it is still going to be y divided by x. Y divided by x. So when that all shakes out, B over R divided by A over R still gives us B over A. So it's not really going to affect our tangent, so to speak. So how would this affect cosecant? Well, instead of being 1 over B like it was, now cosecant is going to be R over B. Instead of, and for secant, it's now going to be R over A. And cotangent is still going to be the same. It's still going to be A over B. Now, I know this is a little Greek to you right now, and we will work some problems with this. I promise you, this is a lot of theory in the beginning. Now, any real number x is the radian measure of some angle in standard form, has a point B that corresponds to the unit circle. And because of that, we can say this for sure. We can say about the domain. Okay? Is all real numbers. Let me go ahead and change this so we see this better. The domain is going to be, this pad only works, you get down to a certain point on the screen and the pad doesn't work as well, so that's why I'm having to change back and forth. Sorry about the confusion. But basically it says this: if we have the domain, we can say it is all real numbers for sine and cosine. And we can also say that the range of sine and cosine is from -1 to 1. Now, how can we say that? Well, think of what we have here. We have a circle. So we infinitely can go around this circle with x values. Infinitely going around here with our x values. Okay? So we can get an infinite number of answers like that. Since we can correspond points on here since we can correspond our points back to our unit circle, we're going to have a domain of all real numbers. But if you notice, no matter where that point is, the answer to the range is always going to be between 1 and -1. Now, it's always going to be between 1 and -1. And we say that is because there's going to always be some number between point P and the point we pick is always going to be between -1 and 1 somehow. Okay? I know that sounds weird right now, but it's because we're dividing by the radius and those sorts of things. But right now, just know this right now. Don't worry so much about the why, because as we get into some of these next sections, we will definitely discuss the why into a little more detail. I'm just kind of giving you a little preview right here. Alright, so hopefully this has been good for you and at least got the theory part of section 2.3 down for you. This is section 2.3, the unit circle. We'll work some problems in the next video. Thank you.